In this video, we are talking about a process called adiabatic process. So, what is that adiabatic process is? First of all, the process in which we keep heat energy of the system constant. That means what? We don't allow the external heat energy to come in, or we don't allow the energy that it has to go out. Whatever the energy that it is there inside, that was kept constant. How that was done? By making that system, adiabatic system, perfectly insulated from the surroundings. Perfectly insulated from the surroundings. That means we don't allow any of the heat energy to either come in or go out. It is perfectly blocked from the surroundings. As it is being perfectly insulated because of internal collisions, what happens is temperature of the system may change, increase or decrease. That implies here heat energy of the system is kept constant, but temperature is not constant. Being temperature is not constant, we can say it is not an isothermal process. I will talk about isothermal process a bit later. According to first law of thermodynamics, dq equal to du plus dw. dq is change in heat energy of the system, but that is not there because we are keeping the heat energy of the system constant. So dq is 0 equal to du plus dw. That implies dw equal to minus du. So work done in this case is equal to change in internal energy, right? This is how we can say. Moreover, as the temperature is not kept constant, Boyle's law is not valid in the case of isothermal process. Boyle's law is valid only when the temperature is constant. That means PV is not equal to constant here. Rather here, PV power gamma is constant. We will prove this at a later stage. Where gamma is ratio of specific heats of the gases Cp divided by Cv. Or we can say P1 V1 power gamma equal to P2 V2 power gamma. That is what adiabatic process is. Well, let us compare this adiabatic process now with an isothermal process. What is? So I just talk only in terms of comparison. Isothermal process. So what is isothermal process? The process in which we keep temperature of the system constant. We keep the temperature of the system constant. So if you compare here in adiabatic process, we keep heat energy of the system constant, but in isothermal process, we keep the temperature of the system constant. Next, how do you make this? By allowing the system perfectly conducting to the surrounding. Perfectly conducting to the surrounding. Here, if you see, here an adiabatic process system is perfectly insulated from the surroundings, whereas in isothermal process, it is perfectly conducting to the surroundings. Next, what we can say is, in isothermal process, temperature is kept constant. Whereas in adiabatic process, temperature is not kept constant, rather heat energy is kept constant. So, next, what we can say. In isothermal process, because the temperature is kept constant, Boyle's law is very much valid here. PV equal to constant. Whereas in adiabatic process, being the temperature is not constant, Boyle's law is not valid. As we have to do, as we have to keep the temperature constant, this process is a very slow process. We shall give enough time to extra heat energy either to get in or get out so that the temperature remains constant. But adiabatic process, we need not keep the temperature constant. So this is need not be a slow process. Rather, adiabatic process is a quick process. That's another difference between isothermal process and adiabatic process. Isothermal process is a slow process. Adiabatic process is a quick process, right? In isothermal process, further, what we have to say, being the temperature is kept constant, Boyle's law is valid. PV equal to constant. Whereas here, PV is not equal to constant. So, these are the so in isothermal process, PV is constant. In adiabatic process, PV is not constant, rather PV power gamma is constant. That's how we can compare adiabatic process and isothermal process. That's it. Thank you for watching.